looking now at the incenter. We've talked about the circumcenter before. We're looking now at a new triangle, or a new center of the triangle called the incenter. The circumcenter was a point with the perpendicular bisectors that created a circle around the triangle. This one we're doing is called the incenter, and the incenter is equally distant from each of the sides. So we're going to have three sides that are all equal to each other. And what that means is that we can create a circle inside the triangle that touches all three sides of that triangle. And where we find this incenter is from the intersection of angle bisectors. So if I were to cut all three of these angles in half, so those are equal, these are equal, and these two are equal, then we're going to have, in the end, one point where they intersect. That point right there is the circumcenter. So, the incenter in this case. So, let's look at some examples of what we're going to do with the incenter. Well, start by saying they want to know what the distance is from this point V to side KL. Well, if these are angle bisectors, then we can say V is an incenter. So, the distance to any of the sides must always be the same. So if this side is 7, that means going to the other two sides is also 7. So no matter what side I'm going to, we're always going to have the same exact distance. Okay, next, measure of angle VJW. Angle VJW is this angle right here. Well, we know this small angle is 19, and this is an angle bisector. So because of that, they both must be the same. They both must be 19 degrees. Now the last step, WKU, is this angle up top. Well, to look at this, we need to look at the entire triangle. We have 180 degrees total. We have 106 from this angle L. We have a 19 over here, and we have another 19 from this part. So whatever is left over would be this whole big angle. So when you do all that subtraction, you have 36 degrees left over for this whole angle. However, we want just the small piece of it, so we need to divide that by 2 to get 18 degrees for that angle. Let's look at another example. I would suggest pausing the video at this point, giving these a try on your own, and when you think you have the answers, go ahead and hit play and see if you got the right ones. Alright, first part tells us to find a distance. Well, here's our direct distance to a side at 5, so that means all distances to sides must be at 5. Measure of QLP. QLP is this angle here. Again, we have an angle bisector. So we should have 50 degrees because these two angles must be the same. Angle PMQ, this small angle up top, is, again, same thing. What do we have left for a whole triangle? We have 50, 50, and 20 already taken. So 180 minus 120, when I add those up, gives me 60 left for the entire angle. This is an angle bisector, so it's cut in half. So we have 30 degrees here. Measure of LPQ. So LPQ is this little angle in here. Well, we have this one, which we said was 50. We have a right angle, and we have this one last angle. So they must all add up to 180. That means that all that's left for LPQ is 40 degrees. Then the last one, the length of MQ, is this side right here. We have a right triangle we're working with right now. So we're going to say A squared plus B squared equals C squared. And the side we don't know is one of the legs. So A squared must stay as it is. The other leg is 5, so 5 squared equals 13 squared. Okay, we'll do no subtraction. Well, we'll do A squared equals 25 plus 169, evaluating the exponents first. So that means A squared will equal 144. Take the square root, and A will equal 12. So 12 is the length of MQ. And in your next video, you will learn how to actually find these incenters. But for now, we know the properties and what we can do with them.